Hello again and welcome to this visualino tutorials. And in the last one we did the analog input to digital output program, in which we stated a threshold, so above that value the LED will be off, and below that value the LED will be on. Now I would like to extend the digital output to several of them instead of just one. So we will still be having the same analog input, and as we recollect from the previous tutorials, we do have some changing values that amount to 770 something, from as low as like maybe 400. So we can say if my hand is quite close on top of the LDR, I will be getting numbers as low as 600, and then if I cast just a lighter shadow I get like 700, and if I remove completely my hand and there is no shadow, full ambient light will be around 770 something. So now instead of having just one threshold, we can use several of them, and instead of just one digital output we can use several, in quite the same fashion as when turn on and off one LED. Now we can use the RGB LED to produce different colors for the different digital outputs. Then producing colors with digital outputs means using pure colors or just secondary colors. As the LEDs we are using are mostly not very good at mixing colors, we will be using primary colors. So the idea is we will be getting green light if there's full ambient light, then blue light if there's a light shadow, and then red light if there's a deeper shadow, meaning our hand is closer. So we're getting kind of a proximity sensor somehow, because the light intensity is associated to the proximity of our hand on top of the LDR. Now this will demonstrate the use of yet another conditional sentence. But before we proceed, I would like to declare some more variables just for the sake of it, and so I can associate the pins to which the RGB LED is connected to some meaningful names instead of just numbers, which are more difficult to remember. So I'm going to declare a global variable called red, and it will equal a number which is the number of the pin to which I'm going to connect the red terminal of the RGB. Let's say this is just pin number 9, and then I'm going to duplicate this a couple of times and get the green, and I will see that I'm connecting the green to number 10, and then blue, and the blue one will be connected to number 11. So of course you can always test the pins connection by plugging a wire into the 5 volts output and changing the wires from pins 9, 10 and 11 accordingly, so the colors are as stated. So now we get names for the pins to which we are going to connect our RGB LED, which is going to work as 3 separated LEDs. Now, the idea is, if the variable sensor is greater than 700, now greater than instead of smaller than, then there is no hand close to it, and the green LED should be shiny. As I told you during the previous video tutorial, once you turn something on with a digital right high, if you want it to be off, you have to turn it off explicitly with a digital right low. So we are going to turn on the green LED and turn off the blue and red in this situation. So I'm going to include the variable green high, and also I will use the variable blue low and the variable red low. And then there's no else, indeed, because everything I'm doing is inside this statement. I'm turning on or off every single LED. So I can actually change the if else for just an if, and I can get back to the regular if by removing the else which is inside here, dragging and dropping it there and clicking on the blue star again. So this is the condition for green, which means full ambient light. Now I'm going for the condition for blue, which is a digital output corresponding to an intermediate region. That will be the mix of two conditions. The first condition is if the sensor reading is greater than the lower limit, then turn the red low and the blue high. But also, if at the same time the condition is smaller than 700, the top limit, then I should turn the green low and the blue high, and also the red low. So, if you want a digital output coming not from just one, let's say half of sensor input, but from an intermediate region, that's just the overlapping of the two conditions. And we overlap two conditions if we use a logic AND, which means condition before should be true, and at the same time the condition after should be true also for the conditional to execute the code. So I'm going to duplicate this and modify both the condition and the output. So now the condition is going to be, if the variable is bigger than the low limit, and the low limit, we'll say it's about 500, and the condition is smaller than the higher limit, and I'm going to duplicate this and change this into a smaller than, and the higher limit is 600. So for values between 500 and 600 I want the blue to be on, so I turn the blue high. So the state for the green digital write pin is going to be low, and the red is going to be low also. And now the last part will be for the red to be on, and that is when the light is dimmer because my hand is closer, and then the reading is below one value only. So if the reading is below 500, that means I'm closer, and I want the red to turn on, so the red will be high, and blue and green will be low. So as I take care of every 3 digital outputs in each if, I don't need any else or else if or whatever. And those 3 conditions cover the full range from 0 to 500, from 500 to 600. I'm sorry, that's not wrong. That's not right. This should cover all the range, so this should be 700. Sorry, and I guess I said before 600 for this because if not, my hand should be too close. So that's it. Okay, my mistake. Now it's better. As I said, this should cover the full range. So this part is from 0 to 600, this is from 600 to 700, and this is from 700 and above. As you may have noticed, readings don't get that low. They don't get to 0, they get around 500 and something, and they don't get so high with a midline. They get just about 778 or something. So that's the same analog input, but now there are 3 different digital outputs with 3 different sets of conditions. 2 of them are one condition, and the other one is 2 conditions that have to be fulfilled together. Okay, that was all. Thank you. In the next tutorial, we'll give it a new turn to this idea.